speed in Breeze 3.
Yeah, that's what I'm saying. The key was different. So I just changed it now.
Oh, I think we might have just gone.
Oh, we're live.
We are live. Yes.
All right.
Woo.
Jessica, do you want to do the intro again?
Okay, yes. Okay, wow. That was quite the technical difficulty. So anybody who's been waiting, sorry about that. And thank you for sticking around. My name is Jessica Levesque. I am not a technology whiz, clearly, based on the malfunctions we've been having. But I am the executive director at C4, Cryptocurrency Certification Consortium, and we do education and certification in the blockchain space. And today we're joined with Shayan and Jeremy. Shayan is our CEP Committee Chair. Shayan, would you introduce yourself and explain a little bit?
Sure. Thanks, Jessica. So I'm Shayan, currently CTO at Ether Capital. I work like as a smart contract security auditor. I've done like education. I have a podcast in Farsi on the side. There's like a lot of like things going on, and I'm happy to have my PhD supervisor also here, Dr. Jeremy Clark, and we can pass the mic.
Yes, thank you. So like Cheyenne said, Jeremy Clark is here with us today. Jeremy, would you introduce yourself? I know you and Cheyenne already know each other. Maybe we can talk a little bit about that later, but first let's introduce who you are, please.
Yeah, no worries. So I'm Jeremy Clark, as mentioned. I'm at Concordia University in Montreal. I'm an associate professor. I also hold an industrial research chair that's sponsored by Raymond Shabbat Grant Thornton. And yeah, so I do research on blockchain technology, mostly Ethereum-based research. I started working on Bitcoin in the early days of Bitcoin, and I have maybe five to seven PhD and master students, including Shayan, who are doing research projects. And we work with government and we work with industry. And yeah, we look at different topics. I'm sure we'll get into some of that.
Yes, very cool. So thank you guys for being here today. So we wanted to do a stream to talk a little bit about what the state of education is with blockchain technology and kind of why it's so important, what it means. So why don't we start by just defining what we mean by blockchain technology? If you're totally new to the space, those words might not mean anything put together, or you may have seen the word blockchain. It's a buzzword that's used kind of all over the place, and what you are seeing in the media might not be an accurate definition of what blockchain technology actually is. So Jeremy or Cheyenne, does one of you want to jump in to explain what a blockchain is and what blockchain technology means?
Yeah, Cheyenne's looking at me to differ. Okay, so blockchain technology is a new technology that came out when Bitcoin came out. And basically what it does is it lets a bunch of computers that are all over the world, anonymous, no one knows who they are, anyone can join this group or leave at any time. And it basically lets them try to compute computations and make sure that those computations are done accurately. So the computations could concern a financial system, like how money moves around and making sure that people don't spend money they don't have and those types of things. Or in the case of Ethereum, it could be more general code. It could be running a market, could be distributing domain names, whatever application you have in mind. And I'll note that, so the idea of blockchain itself was sort of an extension of ideas that existed in the 80s and the 90s. So it wasn't completely novel. It wasn't like it just dropped and then all of a sudden you could do these distributed or decentralized computations. But the main contribution of Bitcoin's blockchain was that anybody could join or leave the network at any time. So prior to that, we knew how to do it, but you would have to have someone that was like the master of the system and they had the list of people that were allowed to join. And if those people were bad, they would kick them out of the network. And so now we have the term permissioned blockchain, and permissioned blockchain sounds like it was an idea that came after blockchain, but it was actually sort of rewinding the clock back to like the kinds of things that we had in the 90s and earlier on how you can do the same type of computation, but you have some control over who the participants are. Now, permission blockchains did take some of the ideas out of Bitcoin's blockchain, like the cryptographic structures and things like that. So it's kind of a merge, I guess, of the fully decentralized blockchain that came from Bitcoin, and these earlier ideas, which were called fault tolerant systems or Byzantine fault tolerant systems back in the early literature.
Yeah, I love that you brought that up, that it wasn't all new technology that just sort of like popped in. There was a bunch of things that preceded it, and that is how blockchain technology came together within Bitcoin. And actually in the white paper, the word blockchain is never used. It's blocks and chain, but it's never put together. So it didn't even start then. It was afterwards where humans began to put it together from what Satoshi had put in there.
Right. I'm not sure the extent that Satoshi even realized how general the idea was. Like he developed it obviously so that it would work for Bitcoin. But I don't know that in his mind, he even necessarily separated out what blockchain was doing and how it could be a more generic thing. But he certainly had the idea that you could run computations on top of it. And he had this scripting language, but it's very limited in terms of what it does. So he probably could have got to something like Ethereum with his concept, but he wouldn't have considered permission blockchains or things like that necessarily. We did write a paper that was fairly popular. So myself and a colleague at Princeton, Arvind Narayan, and it's called Bitcoin's Academic Pedigree. And we have this chart of basically this 5 or 6 key ideas in Bitcoin. And you can see they started in the 1980s, and then we kind of trace them, and then they all merge in terms of Bitcoin itself. And I remember before we wrote that paper, I was reading some of the papers that Satoshi cited in the original white paper. And one of them was this paper from, if I recall correctly, 1997, but I might have the date wrong. It was by Haber and Stornetta. And I remember opening it up, and there's a picture of the blockchain in this paper from 1997. Like the exact same picture you see in every textbook, every explainer of how blockchain works, the Merkle tree, and then it's tied back to like the previous blocks. And I just looked at it, I'm like, whoa, like I didn't realize how close this design was to the existing work. And that was kind of an eye-opening moment for me. And I think Arvind had the similar moment. And that's where we thought that it would be important to show everyone that like these ideas they didn't just come out of the sky, right? And it also gives legitimacy to it as well, right? So people were very skeptical of Bitcoin in the early days. And so if you can show them, hey, this actually isn't so different than the stuff that you've been studying for the last 20 years, it's just a different combination of those ideas, then it makes it more legitimate, and people are more eager to get working on it and treat it seriously from an academic perspective.
Yeah, I just put a link to that, to the abstract to that paper you were talking about that you wrote in the chat in YouTube, if anyone's interested in reading more about it.
Yeah, I just want to say like that that's kind of like trade-off between how as a society we value like innovation versus actually like the gradual making of something. So some people want to say like this is the first, but it's kind of like a mix of like everything that comes before that.
That's such a good point. Like nothing just evolves in a vacuum suddenly, right? Not nothing, I guess I shouldn't say that. But majority of things that become innovative and important, there's like this long history that leads up to it. And that's the same thing with Bitcoin. It didn't just like, cryptography wasn't invented at the same time that Bitcoin was, and digital signatures and all that. So it's like all of these different pieces that had to come together in order for Bitcoin to become the first cryptocurrency and the first blockchain. So why don't we talk a little bit, I know you talked a bit, Jeremy, about permission, either permissionless or permission blockchains. We also use the term open or closed blockchains. Do you want to explain a little bit about what we mean by specifically permissioned or permissionless and what that looks like on maybe more of a global scale? Like what does that mean to the world to have something that's permissionless?
Sure. So first off, there are different terms. So some people use the term permissioned, closed, consortium, blockchain. I've heard different terms for it. And essentially, the reason that Bitcoin is expensive, you hear about the hydro that's being used in proof of work. And I won't go through all those details, but these are like kind of the keywords that you've probably heard if you follow the news. The reason all of that comes into play is because Bitcoin is it's operating in an open environment. So it's a very expensive protocol to run. So if you want a cheaper, faster, more efficient, more scalable version of it, you can sprinkle a little bit of trust into the system, and you can get that efficiency that comes back out. But the trust takes the form of basically having a list of who's allowed to participate, who's allowed to be a miner, if you want, in Bitcoin terminology, on your network, right? And these are the only people that are allowed to be miners. And if other people start, saying that, oh, that miner's wrong, or this should be the new block, you just ignore them completely, right? Then it turns into a simple voting protocol. You can do majority rules or some variation on it. And because I can't join the network with 1,000 nodes, I can't become the majority by cheating, right? That's the problem in Bitcoin, is that you can become the majority by cheating, or that was the problem that Bitcoin was trying to solve, right? So you can just say, I'm 10,000 computers, give me 10,000 votes, right? And so the proof of work is an elegant solution to it, because it says, if you're really 10,000 computers, let's see you compute these puzzles as if you're 10,000 computers. And yeah.
Mm-hmm. You talked a little bit before, I don't know if this is something you feel comfortable explaining, but fault tolerance and like the Byzantine generals problem. I feel like that example is something that was really interesting. And for me, like when I first read it, I was like, okay, this makes more sense and why this was a problem that needed to be solved. Does one of you feel comfortable explaining when we talk about fault tolerance and the Byzantine generals problem, what we mean by that?
Sure. So I can sketch it out anyways, I'll give you the 30-second. It's obviously a very deep technical issue and the math gets really hard. But at a high level, sorry? Yeah.
That's high level, yes.
At a high level, it's actually pretty simple. So imagine you have 100 nodes that are on the network and you have a list of them. So you go out and you find 100 people and they're all going to run nodes for you. And you're looking at transaction by transaction and you're voting on whether it's valid or not. And everyone has a set of rules, there's a sort of acceptance of what a valid transaction is, okay? Now, some of the nodes are malicious, so they're going to mark valid transactions as invalid, right? And they're going to mark invalid transactions as valid, okay? So you know it. So if you were listening in, you would see that, I don't know, 70% of the network saying this is a valid transaction and 30% saying it's invalid, right? And you know that there's some malicious nodes. So you're trying to decide whether it's valid or not. And so what you're going to do is you're going to run kind of like a voting protocol, okay? So the voting protocol, all the nodes are going to say whether they think it's valid or invalid, and then you're just going to go by majority. Now, there's a further twist, which is in order for you to vote, you need to tell each other what your vote is. But we're going to assume that not every node is connected to every other node on the network. Or even if they are, if I'm voting invalid, when I tell Shayan's like, how are you voting, Jeremy? I'll say, I'm voting valid. You're going to ask me how am I voting? I tell you invalid, right? So I basically equivocate. I'm giving an inconsistent message. So that's another kind of malicious behavior that you can do. Or maybe Jessica, you're not connected to Shayan, right? But I am. I'm connected to both of you. So Shayan's like, hey, how did Jessica vote? And I say, oh, she voted invalid, but really you voted valid, right? So anytime you're relaying these messages, the people in the middle can change them, and they can tell different people different versions of events. And so anyways, the point is to give you the idea that it gets really complicated. You can't just run a simple voting protocol. It's very easy if you have a public bulletin board and everyone writes their votes, everyone can see it, then that kind of solves the problem for you in a very simple way. But when you have this sort of partially connected network and then nodes go offline or they take too long responding and things like that, you have to deal with all these situations, right? So the major results show that if you have 2/3 to 3/4 of your network honest and participating and live, et cetera, you can tolerate, you can run the system and it will work. So that's basically 30, 40 years of literature and then they have all sorts of different assumptions that they make about what the network looks like and what the communication looks like and things like that. And then you get different numbers for different network models.
Yeah, I like that point about you don't know who or each node is. And so people can, if the system isn't set up correctly, people can tell somebody information that isn't true. So there has to be a way to trust in a group of people that doesn't have that one authority. that one figure that you're going to, that you can assume, is telling you the truth, which we know isn't always accurate either. But why don't we talk a little, so we've discussed what this technology is, but why do we need it? So we said this didn't just evolve overnight. This was sort of a long string of different types of technology that came together in order to start what is now known as blockchain technology. But why do we need this? You talked a little bit about that in terms of from a theoretical level, but what is it doing for us now as just people? And when do we not need a blockchain? So when do we use one? When don't we use one? And some of it might be opinion, but what do you two think?
I've been talking a lot. You want to answer?
Yeah, I just want to say, one thing Jeremy was saying, I can link that to this question, was about that bulletin board, that board that is there that you put the votes on. That is similar to a database, right? If you're running a network, a database should hold all the data, in a non-blockchain world. And the place that blockchain comes in handy is if you can't trust one entity to run that database. And you want everyone to have a copy. There are different ways of doing it, as we were mentioning, closed blockchains or permission blockchain, also in another way of doing this, but that's kind of going one step back and using just cryptography to make sure the data is integrity of the data is more on that. But when we need blockchain is when we don't want to trust one entity to run that database. And we want to have a shared copy and everywhere. And one of the examples that Jeremy used before that was one of my go-to examples. I think maybe he can explain. It was a supply chain and how countries can't trust each other in running that database. And I would like to hear that again. That's an interesting way of going through this question.
Yeah. So in that case, it's I always say it's kind of a political question. Whenever you have a server or a database and you want to put it up, somebody owns it at the end of the day. They own the data and they control access to it, right? So they can turn your access on or off. They can change the rules of who has access and things like that. And there's a lot of natural scenarios where you don't have, it would be great to have a common database or a common server that can execute computations across a bunch of different participants, but there's no natural person who would be I'm the one that's going to take ownership of this server, and everyone else is going to be okay with that, right? They're all going to trust it, right? So supply chain, for example, it's going to involve transport companies, it's going to involve governments, port authorities, which are kind of like municipal governments, and so if you want to track something across the world, the possession of it it's going through all these different borders and different companies are taking it and things like that. And so if the US government says, hey, we're going to put the database up and you can track, everyone starts writing into our database even before it enters the US, right? And even after it leaves the US, a lot of other countries aren't going to be happy with that, right? They're not going to be happy giving that amount of control to the US government. So a blockchain can come in and it can say, well, there's no one in charge, right? We all agree we're going to write into the same common blockchain, but it's going to work no one of us can override any of the access issues. As long as a majority of us are so happy with the system, it's going to continue running. Yeah, so yeah. And then in terms of use cases, I first off, I always encourage people to think, to start with the assumption that you don't need a blockchain, right? I think we went through 5 or even longer years of people doing the opposite. They're oh, we have this blockchain, it's a solution looking for a problem. And it was proposed to solve all sorts of different issues, right? I like to come back at it the other way around, where it's, where you're okay, I really understand the domain and I understand all the problems in the domain. And now I can see exactly where a blockchain might work. So to give you a concrete example, before I worked on blockchain, I worked a lot on voting technologies. And blockchain voting is this thing that everyone says. They're oh, no one trusts the voting system, so let's put it on a blockchain, then you don't have to trust it, which is not accurate at all. But once you learn the domain of voting and you learn what the problems are, and you come up with your list of like the top 10 problems that you have to solve if you want to do a secure voting system, you realize that it's not that blockchain can't do anything, right? It's not like, oh, blockchain is useless, but it's not solving the first problem, second problem, third problem on your list, right? It might solve the 8th problem on your list, but there's still a lot of other stuff. Right. And so you could use it to make a very narrow contribution to solving one specific problem that you have. And so that's the that's sort of how I approach it personally.
Yeah, that's an interesting point. Sorry, I just want to add something. That's an interesting point about saying how sometimes permission blockchain are not necessarily even a blockchain. You're just fitting blockchain in there in some way, which you can just use some cryptography and fix that.
Yeah. Sometimes when people say blockchain, they don't even mean like a blockchain. They just mean digitization, right? And they're in their mind, it's just a computer and there's a server sitting there and it's doing everything. You do have to be careful when you talk to people. Like, I've seen a lot of fights break out just because two different people have a different definition of what they mean by blockchain.
It's interesting. I feel like I think you pointed this out earlier, Jeremy, but over the last few years, it's changed. Like, I don't think it's as big of a buzzword now in terms of like randomly just tossing it into like marketing materials. So I remember this was years ago, we received something about, this was like legalization of marijuana. I live in Chicago. And then it was something like how blockchain technology is going to fix this. And we got this pamphlet. I don't even know what it was from, but my partner was like, oh, like, what is this? And I was like, this doesn't even make any sense. Like, reading the language, he was like, I don't get it. I was like, that's because it doesn't mean anything. Like, it's just a bunch of BS put together with these fancy graphics. So that if people are like, oh, like this is innovative and I want to legalize marijuana. So like, let's combine it and this is going to solve all of the problems. But it was like, so once we went through it, he's like, oh, okay, like I get why it doesn't make any sense. But if you don't understand how the technology works and, he's not in this space, it doesn't mean anything. It just seems like something cool. So I think that I see that less, but it's still definitely out there.
Yeah, I agree. We once read like 200 white papers from industry. So this is more reputable. It's not random pamphlets that are coming to you, but it's still like, big companies that don't know blockchain specifically, right? And they'll write like some white paper on like, here's where we think it could apply, like to all of the different things that we do. And there just was like a lack of like real ideas. Like they all like kind of repeated the same thing, and almost all the papers, they tell you a lot about like the basics of blockchain. This is what blockchain is. So that's like a third of the paper, right? Just explaining what it is. And then there's a third about like, what are all the problems that they deal with. But then when it comes to like the overlap, okay, how are you going to take thing A and use it to solve thing B? It's just very light. It's just sort of like, well, it looks kind of like it will work, or it reduces trust and there's trust here. So maybe we can use it to reduce trust, or like very vague statements and not a lot of like concrete details. It's just, sort of speculative design. And, but that has changed, I think. Now it's like, there's a demand to like show more details, and a lot of the big industry have given up on trying to do like blanket blockchain everywhere. And, I've heard of consulting companies getting hired to just go through a bank's operations from top to bottom saying, where can we apply blockchain, right? That they're just hired to do that. Like maybe here type of thing. You don't hear that anymore, but there are like specific use cases, and now like there's a lot of concentration on just those use cases and not trying to apply it everywhere.
Yeah, and I think that's why education is so important. And I think that the increased knowledge in the public of how the technology works is making it less like productive for these random companies to be creating these, pamphlets or these reports, or trying to bring in to add something that just says blockchain, because more people that understand how it works are immediately being like, well, that doesn't make any sense. And so it's no longer something that is effective for them, like as a marketing strategy. And so why do it anymore if people are calling them out on it?
Right.
Yeah.
I definitely think that's a large part of it. There's also the part that like blockchain, once you understand it, you realize it's kind of boring. Like, do I care if I'm doing something on my phone? Do I really care if it's blockchain or a database or a server? Maybe I care about the security properties and things like that in a secondary sense. But like when I'm on my phone, I don't care. And I'm not even cognizant of like, oh, when I use this app, it's on a blockchain, and when I use this app, it's on a central server or whatever.
I heard somebody talking about that recently in terms of like at some point, all the apps or a lot more of the apps we're using are going to be dApps, and most people who aren't interested in the technology won't know which is which that they're using, and it won't matter to them necessarily.
Right.
And dApps, for anyone listening, are decentralized applications. That's what we're talking about. Well, so, okay, I know we are all in education, interested in educating others. I think it'd be interesting to hear our like origin stories of how we became involved in Bitcoin and Bitcoin education, or Ethereum and Ethereum education, and where, you know, what got us started and how we got to where we are now. Because obviously we're all still trying to educate people in the space, so we think it's super important. Jeremy, do you want to talk a little bit about your story and how you began teaching, either educating yourself or teaching others about this?
Sure. So so my background is in cryptography, so like crypto before Bitcoin, right? And when Bitcoin came out, I was a PhD student at the University of Waterloo. I was working on voting systems using cryptography to try and make sure that you can verify that your vote is in the final tally. It's not modified, but you can't prove to someone else how you voted. Otherwise, you could be coerced or you could sell your vote. And coincidentally, the person I was working with the most, his name's David Chom, and he invented this area of cryptographic voting. He had also invented digital cash. So he was the sort of originator, like the year I was born, like kind of thing. He was writing papers about digital cash. And he tried to do digital cash.
That you worked with him.
Okay.
Really cool.
Yeah, I still work with him today. We have one project, but anyways, so I had an interest in digital cash a bit because I was working with him, and there's a lot of overlap too between the ideas in voting and digital cash. So when Bitcoin first came out, no one really took it seriously because every 6 months someone had some crazy idea on how to do digital cash, and they were all garbage except for Bitcoin. And Bitcoin didn't do enough to really, I mean, the test of time was the test that worked, right? But it didn't really do enough to try and convince people, you know, just from the white paper alone, or just like, oh, just go run our software or whatever. So I think it took academia like a year or two to come around to it. In 2011, I started writing a paper. It was published in early 2012. And that was like the third, by my count, academic paper ever on Bitcoin. And so, so anyway, so I came around to it, I guess, a little sooner than others. And then we went through this period of trying to convince other researchers that this is a good topic and it's valuable, and there's academic contributions that you can make. And now you don't have to make that argument at all because there's thousands of papers, you know, and lots of venues and things for those papers. So anyway, that's on the research side. Now I'm sitting as a professor, and so I'm teaching crypto courses, like just crypto courses, and I'm teaching security courses as well. And I think, well, maybe Bitcoin, there's enough there to sustain a course, an academic course. Like, could you do an academic course where the very first time I taught the crypto course, I had a lecture on Bitcoin at the end. I'm like, here's an application of cryptography. But then I started thinking about, like, could you actually do an entire course just about Bitcoin and blockchain? And would it be enough? Is there enough material there really to sustain it? And I had some colleagues that mostly at Princeton that were I was collaborating with on some of the papers. And so we were all thinking sort of together about the same issue. And they said, yeah, you could do a course. We're going to do like a free MOOC about it, and we'll put it up on Coursera, and we'll put it up on YouTube. And I wasn't in New Jersey at the time, so it was hard for me to collaborate, but I did fly down and do one of the lectures, sort of a bonus lecture at the end for that series, but it was like 99% their work. And so, yeah, so they did the first version of it. And then this maybe isn't interesting to everyone, but as an academic, it's really interesting. Then they had this brilliant idea of, let's take our lectures, we'll get someone to transcribe them. So now we have our lectures as text, and then we'll just go through the text and we'll polish it up and we'll turn it into a textbook. And so that's exactly what they did. So I actually have the textbook here. It's my one prop. So this is Bitcoin and Cryptocurrency Technologies, Princeton University Press, and you can get it free as a PDF online. It's kind of old now. We talk about maybe updating it or doing an Ethereum version or something like that. But as for now, this is what we have. And then I wrote the foreword to the textbook itself. So I'm not an author on it, but I wrote the foreword. But anyway, that textbook is like a one-to-one mapping to the lectures that were in this course. And so after that, I said, it was an easy sell to my university. I just said, Princeton has a course, like we can have a course too. If they can do it, of course, we can do it. And by that time, like Stanford and MIT had done courses as well. And so I just pitched it to the university. They said, fine. And then I started a course. And as far as I know, it's the first Bitcoin course, blockchain course in Canada. And it's one of the first, like probably the first 10 in the world.
Okay, that's super cool. I'm such an academic geek. Like, I love this sort of stuff. And I really like what you're talking about in terms of repurposing. So like you use this course material and then you put it into a textbook. So one of the reasons why I love that as an educator is it's giving people different forms of representation for how they want to learn, which is something that I really believe in. And I think it's extremely important when we're talking about a technology that has many kind of foreign aspects to it for like the layperson like me. I don't have a computer science cryptography background. So when I started to learn about this, I wasn't really sure where to go, what was accurate. And then I might find something that differed slightly between the way it was written and the way it was the visual. And then I wasn't able to sort of figure out which one was accurate and what the differences were because it was outside my kind of common core of knowledge. And so that's one of the things we have for our certified Bitcoin professional course. We also have a prep book that goes along with it because like for me, I like to see visuals, but I also really need to read things. If I just hear it out loud, it doesn't sit with me. But so I love that you repurpose the content in multiple ways so that people are able to access it. And that's something that, we really believe in at C4, which is why we have written content and video content as well. Do you love teaching about this?
So I'll just add that when I was a student, I was the one that like never went to class. And then a few days before the exam, I would curl up with the textbook in a corner and, read it for 10 hours straight. And that's how I learned the course, right? And so
you sound like me.
I'm 100% a textbook. And the other thing too about this book is the writing is very conversational, I think, like more than, it's not very formal. It's not like some textbooks are very formal. There's a lot of notation, but because this was the original text was the transcript of someone like lecturing about it, it ends up, obviously we went back and reinserted formulas and pictures and things like that. There's also a lot of graphics because it was originally a lecture where there were slides for every single idea that you had. And so it tends to be very conversational in how it's written, and there's a lot of visual material that goes along with it. And so because the textbook we didn't sit down to just write a textbook because it sort of has this like early history as coming from lectures, it really shaped the way that the textbook came out. So that's either a pro or a con. It depends on what you want. Some people want a more technical explanation, or they want the notation because they're writing a paper and they want to see kind of what the standard notation is. Whereas this is really about like, let's give you the intuition of it, right? Or like Mastering Bitcoin, which I see on your shelf behind you. That's another like canonical book, right? But very different from this one, right? So like that book doesn't really give you the intuition, but if you're a programmer, that's the book absolutely 100% you want. You don't want, maybe you read this for the intuition, but it's not going to help you program, right?
And that's why we need different types of books, different types of content, because it's a much larger topic than, somebody asked me if they could read the white paper and pass the certified Bitcoin professional exam. And I said, well, no, it's quite a bit more than that. There's so many other aspects. And I thought it was a good question, but at this point, it's important to read and understand, but there's so many different like use cases, ways to understand it. But I'm gonna have to check out your book. I just put a link to it in our chat as well for anyone else who wants to read it too. But I think that's pretty interesting. And I find it fascinating when people like, there's such a difference between someone who started with cryptography or like Shayan, who is a computer. Would you call yourself a computer scientist, a coder? Like what's a developer? What's
yeah, like I can go through my story too if that.
Yeah, I'd love for you to.
Was that like a segue to get into that?
Yeah.
So my background is computer science and security, and so I guess I can just jump into the story. So in like 2011, 2012, I was working on anomaly detection on Linux kernel, and it was deep down in Linux kernel. And Bitcoin was this other thing on the side, and it kind of comes back to that permissionless part, because growing up in Iran, digital cash or digital payment was almost impossible. And because you had layers of permissions that you had to pass through, and because of political reasons, you couldn't. And Bitcoin was out there, anyone could use it. You don't have to ask anyone to use it. And that was too dreamy for me. And coming from a security background, I was like, this is too good to be true. It doesn't work. And I spent like 4 or 5 months trying to break it. And while doing that, I think there was one point that basically I read everything on bitcointalk.org, the forum, and I was like, seems to be working. I actually like played around and it worked. And that's where I kind of decided that this is the thing I want to work on. And I remember that that's where actually Jeremy started at Concordia University. So I had like a chat with him, and I went to my previous supervisor and my master's, and I said, like, this is the topic I want to work on. And he came back to me similar to what Jeremy was saying that there's not that many papers on this, so it's not a good subject. I'm like, but that's exactly why I want to work on this. So kind of like fast forwarding, I switched supervisor and started working with Jeremy, working on Bitcoin usability as like businesses, users, and some others, which taught me a lot on how wallets work. Usability is a big aspect that I learned while doing that paper. And it gave me a lot of ideas on how to look at applications and how users interact with them. So while I was working there, basically I was based in Montreal. So the first summer I decided to learn French. And by the end of the summer, I learned Python. It was way more useful. So basically I knew Python. My background was security. I was working on Bitcoin. And there was this email that actually Jeremy forwarded that, hey, there's this guy looking for someone that writes Python, works on Bitcoin, and has a security background. And it was a Bitcoin ATM company in Ottawa. And that's where for me was just jumping head into like this protocol, and I had to write an application to create Bitcoin transactions. And that's where actually the Bitcoin, mastering Bitcoin came in really handy as to learn what that works. And I think I actually fixed some of the issues there. So if you look at the website, I'm listed as like someone that fixed issues in that bug. And one of the other parts was like on the other side, I started like creating websites and other thing Farsi, because I noticed that language is a big barrier to get most of the people to get into this space. Like already we have a lot of cryptographic terminology there that people get confused, but aside from like the whole English language on the side. But the other really interesting experience I had was the course that Jeremy was mentioning. So I was a TA in that course, and not the first round, the second round of the course. And I wanted to like make sure the students are not just learning a theory and actually playing around with it. So I spent one of the exercises or take-home homeworks. I was about to design them. It took me 4 days to come up with one question because I wanted to make sure they actually open Remix, they start coding Solidity, something really easy, but I wanted to get them to try testnet, to try it out. It's funny that like it took me 4 or 5 days with creating video to create that assignment. And when everyone submitted, first of all, I got really good feedback about how they felt what smart contract is, but it took me like 15 minutes to mark 100 assignments because I wrote a script, its own blockchain. It just fixed everything, like basically marked everyone as a script. It was like really interesting experience. And it was really like people came back to me afterwards and talking about how the idea of smart contract is one thing, it's kind of like foreign and they don't know what that means. And when they actually click around and interact with the smart contract, even on testnet, even on like a kind of simulated environment, it just opens up so many ideas as like, oh, wow, we can do this, or we can do that. And that's one of the things I really want to with C4 and all other work to get people to play around with it, not just like read the books. It's good to start there, but this is a technology that you don't have to ask permission to use it. You can even break things without asking anyone. So
where would you recommend someone goes if they want to start doing that? Like if they want to go on testnet, like what do you think makes the most sense for someone if they're listening to this and they're like, oh, that sounds kind of fun. What do I do?
There's one thing called Crypto Zombie, which is a game. They can click around, and it's kind of a game into getting programming. There is another one recently Griff created, it's called Speedrun Ethereum, I think, which is like examples of use cases with the code. Speedrun Ethereum, I think. Speedrunethereum.com, which has like different use cases. You can start coding and playing around with testnet and others. There are different resources out there for this, and these two would be a good example to play around.
Okay, maybe we can link to that on Twitter later. We can share some of those so people can find it if they want to play around. Because I do think like the learning curve is hard to, if you're outside of this space to jump in. And then if you don't have coding background or you don't know where to go or who to trust, it can be difficult, I think it's easier now in some ways because there's a lot more information than at least when I started. And when I first started learning about Bitcoin in 2014, I felt like there wasn't that much. And then in 2017, there was a lot, when I started to get into it more, there was a lot more, but I didn't know who to go to, where to go, that kind of a thing. So there's more resources now, but it's like if you don't know anything about it, how do you know who to trust, right? Which is kind of, I guess, why we're all invested in teaching about this so that people know where to go and how to get started.
Mm-hmm. And also the course that Jeremy was talking about, all the content are online, I think, right? Like everything's video.
Yeah. So for my course, it's all on YouTube. So anyone can watch it. It's on my website as well.
I'll link to your website too.
Yeah. And so it covers Bitcoin and Ethereum and now a bit of DeFi at the end. And then the earlier Coursera one I mentioned, which is linked to the textbook. That one's also all online. You can watch it on YouTube free or on Coursera if you want credit for it. And it's a little older though, so it doesn't cover Ethereum. Or maybe Ethereum's mentioned in passing, but it's really on Bitcoin and the core ideas behind Bitcoin.
That's one of the challenges, I think, with teaching anything in this space is that it does change quickly. There's constantly new things. So to keep up with either textbooks or courses or, infographics, whatever it is, like our exams, you have to keep at it and keep up with what is changing and then add it to whatever the material is. And it's really hard to do for anyone who hasn't spent much time in education. The kind of the lift, I would say, for updating materials can be, pretty extensive. And then if it changes again, like we're experiencing that with our cryptocurrency security standard auditor exam, the standard is like, I feel like we keep running because we want to have it as fresh and relevant and useful as possible. So it keeps like getting delayed as we make changes to it, because if it's not updated, then it's no longer useful. So we have to keep doing that, which I think we're doing a good job. But with all of this technology, anything that isn't static, which is, I guess, most things, it's difficult to keep updating to make sure that your content is still useful and is going to be giving people what they need.
Yeah, so I think that's probably the biggest difference between you as an educator and me, for example. So in university, it's kind of like we take the opposite perspective. So I try not to teach the details and I try not to show them what's new and fresh. We put more emphasis on like the foundation. So like, these are the things that will not change, right? And we don't really care about like how exactly do you do it? Like you need a digital signature. It doesn't matter if it's ECDSA over an elliptic curve or whatever. Like those details do not matter at all. It's just know that there's this black box. It's a signature. This is how it behaves, and this is why you need it, kind of thing. And so we do a lot of black boxing of like the smaller technical details. And like even when I get to Ethereum in the course, I'm just like, assume it works like Bitcoin. It doesn't. But just it doesn't matter. If you understand how Bitcoin works, you have a mental model of what a blockchain is. You can assume that Ethereum works the same way, and it's not going to get you into trouble unless if you're doing some like deep, low-level stuff that's way beyond the like scope of the course or whatever. So we give abstractions, we give models. We don't always go deep into the details. I try not to keep it current. With DeFi, I was kind of reluctant to add it, but I said, there's a couple concepts in DeFi that have been around for 5 years now. I think it's time to add them to the course. So, I'm not going to add something that just came out yesterday, but if it's been around for 5 years and it's sort of the same idea, it's just being repeated in different projects, but it's the same core idea, I'll at least teach the core idea. I'm not going to go into all the details and the governance tokens and all the different levers that you can turn, but I will teach you like the very basics, and that should hopefully help you. It will give you a head start when you learn a new protocol, right? So you're not going to walk out knowing how MakerDAO works or Compound or whatever, but you will know, oh, lending always works kind of like this way, or a stable coin, there's basically 3 ways of doing a stable coin, and these are the 3 ways of doing it. And I can see that this new project, Nova or whatever, is using this one like kind of idea, and it's not going to work because it uses that idea.
Yeah, and to your point, like, so it's really challenging because even like if you run this course next year, you can't really say Ethereum works on like some Bitcoin, because then proof of stake is in, like merges in. Like that's one of the challenges we had with CEP exam, that a lot of them, like even with like EIP 1559, which the fee structure changed. As you said, it's detailed, but when you do like Ethereum exam, that detail is the part of it. But proof of stake would change a lot of things in there, and that's one of the reasons. Like I was in a podcast a while ago that they want to talk about like I think even C4 we talked about that, but like the difference between Bitcoin and Ethereum, like the whole thing, it was about that. And I had to actually meditate before that to be able to like sit through. Like I was like, I have to go through this again, so I have to like be patient. But it's going to be more challenging later on like how to teach that. And I feel like one thing you mentioned about like governance, we're going to see the governance design in like poli-sci, like political science or some other courses coming up soon, because it's becoming its own field. Like we were talking about tokenomics.
Tokenomics, you got it.
Tokenomics, yeah. That has been a conversation for the last few years, but now you're seeing that is evolving into the governing its own protocol. So the design comes in a lot of different flavors. So it's going to be interesting to see. I don't think it's a computer science thing anymore, just that. It's like all over the place. So it's exciting to see.
Yeah, I agree. Jeremy, I'm going to have to check out your course and look at it. I have been in education, crypto education for 5 years now. And we've done our CBP course, and we're working on writing our Ethereum professional prep book, which will then be turned into a course. And I taught a intro, like cryptocurrency basics course at a community college this past semester. And it was really humbling. What I've done has been on video, or it's been with other people who can jump in and give another example, but being the sole person in the class that's going through and kind of explaining it, and having the questions come up and thinking, okay, how do I explain this with that question? And how do I explain kind of like the basics leading up to it without getting super in the weeds and too in depth where you lose people? But if, you don't teach any of it, it doesn't seem like it's innovative or new. And so kind of like walking that fine line between what's too much and what isn't enough. And like Shayan was saying too, with like, okay, I'm talking about Ethereum. How much about proof of work versus proof of stake? Is that something that's even important to cover in an intro course? And like, how do you know how much to talk about? I always say it takes, at least for me, 3 times to teach a course before I'm like, okay, I feel good about this, because there's always some things where this is going to be a great, in-class activity, and then it tanks and you're like, okay, I'm never doing that again. And you don't really know until you've experienced it. But with this, since things change, at least for me, it's like, I'm already thinking, how am I going to do things differently next semester with it? And then I'm thinking, well, if proof of stake goes through, then what's that going to look like? So, yeah, I want to take the course that you've done and see how you did it, because obviously the best way to be a good teacher is to see what other teachers do that works well.
Right. Yeah, so my course is very specific to the context as well that it's being taught in. So these are graduate students who have some sort of undergrad already in CS or ECE. In a university environment, like you can losing the audience is terrible if you're giving a talk or a presentation. But in class, it's kind of like the onus on the student to like catch up kind of thing. And so I don't try to do it deliberately. Some professors do, right? But I deliberately do not try to lose anyone. But at the same time, if I can't drag like 100% of the class through the content. Eventually, you just have to like sort of move on. And the way that course is structured is it's very in the weeds right away. It's sort of like, let's just go walk through the weeds. And I think it takes like, I forget how I sectioned it up in terms of weeks and things like that, but it takes like 5 or 6 lectures before you even see Bitcoin or blockchain. So it's like, let's go through all the crypto one by one. And then eventually, like, let's get all the pieces lying on the ground. And then once we have it, then we're going to build this kind of thing. And so you have to have a little bit of faith. But in a university course, the students have, they can drop it, but like they, you sort of have to go through the course anyway. So you don't, yeah. So anyways, I think it's a really good course. I'm really proud of it. And I like the way that it came out, but just so you know, it is like, it's being taught in a certain context that doesn't necessarily translate well to other contexts where you might want to teach.
Right. Yeah, that makes sense. I actually had a couple questions in the chat. One was, are our courses at C4, our courses and certifications also for developers, or are they just a general introduction on how Bitcoin and Ethereum blockchains work? So the CBP, neither of them are for developers. The CBP is definitely less technical than the CEP. CBP is much more, like we explain it like it's like getting your driver's license. You need to know how to drive the car, what the stick shift is, what the rules are, but you don't need to be able to like
get knowledge test.
Yeah, but the CEP it is more technical, but you don't need to be a developer to pass that. I'm not, and I'm a CEP.
Yeah, they're not getting into the coding part, but if you want to code, it's really good to get this to know about the context.
Yeah, this is a great way to like kind of, if you're interested in learning more, to introduce and start to get more information on it. And also we've talked about this quite a bit, but that kind of like self-empowerment, that proof of knowledge, you've passed it, you can prove that you've understood it. Here are, experts in the field and part of the community who've decided what they think collectively is important for someone to know, to prove that they understand how Ethereum works or how Bitcoin works. And to have that certificate is a way to kind of show to yourself and to others that you understand it. The next question was, any recommended materials to get up to speed on the state of Ethereum today? The merge, L2s, et cetera, and how to evaluate versus others like Solana and Cosmos. Okay, so this is 2 parts. So materials to get up to speed on the state of Ethereum today, and then how to evaluate Ethereum compared to Solana and Cosmos.
So I think that could be a whole course, but like for Ethereum, there's like this newsletter called Week in Ethereum News. It's really good, as like you get this emails about like everything that happened in the last week. But Ethereum is mostly like links, so you have to like click and go through that. It's good for anyone that's specific, because Ethereum is now insanely huge. Like you can go on different parts, like blockchain overall. So if you're interested in client like development, there are links there, tokens there, like all aspects are there. So that's really good. I usually get my news from like Twitter, but it's also so noisy and so all over the place that you might get lost. So that is a good place to go. You can see about the merge, anything L2 regarding Ethereum, but the evaluation versus Solana and Cosmos, it's all over the place. But if Solana is up, then we can look at the block explorer, but if not, then it's down.
Yeah, I think to compare, I think like the first step is to take like a high level and see what it is that you're like, why do you want to learn more about it, and what's your goal with it? Do you want to build on it? Like we know quite a few people right now who are building on using Cosmos, they're building on the IBC, and that's something that they're interested in. I don't know as much about who's using Solana, but I think that like the way to evaluate it is first to come like, what do you want to use it for? Are you looking at it as an investment? Are you looking at it as something you want to build from? And then kind of using that context to look for more information about it. That would be my recommendation. Okay, so anything else we want to talk about before we close? We're at our time. We did start a little bit late thanks to technical difficulties on our end. But anything anyone else wanted to add before we wrap up?
I just want to add something about like we have on the list on misinformation that comes back to like where you get your information, is that whatever you hear, try to like find one or two sources that says the same thing, because we're in the space that people can just say things, everything, and then you need to like find a good resource to like see if that makes sense. One thing I noticed is like last week about there was like some reorg in Beacon Chain. It's too much detail, but it was a technical issue that was not a big deal, but it was not supposed to happen. So they're like working on it, developers, but that news got into like basically the market and people started selling, and there was like affected the price, but no one actually looked deeper to see if this was actually like a big deal or not, which was interesting to see that everyone's paying attention to the developer chat, but they just get the sentiment of is it positive or negative, not necessarily looking deeper into like what that means, which is a good thing. I mean, it's one step further than before, but it's still kind of in this middle ground of going blindly in the market. So that was one of the things I want to say, like whatever you hear, first of all, don't look for the next Bitcoin, next Ethereum, just see what that thing offers, and some of the,
Yeah, I like saying Bitcoin is the next Bitcoin. I like that. Like it does one thing, it's like pretty simple with what it does, and it does it really well. But yeah, I think that's a good way to look at it, Shayan. Anything else, Jeremy?
Like to me, like it comes down to credibility, right? So you want to find credible sources, and unfortunately, they're mixed in with all sorts of noise and uncredible sources. And I don't think there is a rule where you can be like, okay, this is how you can tell whether it's real or not. So it's sort of an art as much as it is a science. And part of it is like you've been around a while, you kind of know the voices and you know who they are, and you sort of know where they stand and things like that. And even like some people will say, like from my perspective, I'm in academia, so we have published papers and they're peer reviewed, right? And so that should be like the gold standard. You could be like, well, stop reading Medium posts and start reading academic papers. But even that like is terrible advice, because there's all these academic publishers that will publish garbage, and it's not even peer, like it might be trivially peer reviewed, but it's not. And students can't tell the difference. I know, like, because I'm like, oh, I've never heard of that venue, and let me look at the program committee. I don't know any of those people, but like I can't write that down, like all the venues that I know and all the people that I know. So, and then academia always lags by a year or two, so you're not going to read about the cutting edge stuff. So yeah, we do a lot of stuff actually in our lab where we try to take knowledge that's like at that stage of like Medium posts, Twitter, that kind of stuff, and elevate it to academic status, and think very critically about it, and not believe what we read, and dig into the details and make sure that we understand it, and maybe coming up with new taxonomies to explain them, all the differences. So these types of papers are called SOK, or systemization of knowledge. So Shayan and I have written a couple, two or three, and with my other students, I've written a couple on where we just look at a topic, oracles or stable coins or whatever the topic is, front running. And and we sort of try and drag that literature up.
I will vouch for that. I read the one on oracles, and I thought it was fascinating. It was really well done.
Yeah, thank you. Thanks to the students they get most of the credit. But anyways, we still struggle with it today, right? Like no one's an expert. And the only other thing I would mention too is that, for example, we did a bunch of projects with Arbitrum, and I was learning the basics of it, and it kept changing. Like there was an actual academic paper at using security, but like the details of what they implemented were completely different than the paper. And they had really good documentation, but then there were some stuff that just wasn't explained. And so at a certain point, you just got to join the Discord and ask, like, look, I've read everything. I've read all your blog posts. I've read the developer guide, and like, I still don't understand how this works, and then just get the authoritative answer. And people that work at companies, they obviously are biased, toward their own service or their own product, but they have thought really hard about how they compare with other services, right? So if you want to know what's the difference between these three L2s, go to each of them and ask them what they think of the others, right? And then take that information and put it all together, because they each will give you a biased view, but they'll give you an untarnished kind of view of what the shortcomings are of all of the competitors. So yeah.
And
but
also that
talking
changes.
to people is helpful.
Yeah, also that changes given the time. Like early on, Ethereum was saying like lower fees, or like a lot of things were that, and changed based on the traffic use case and some other. So it's a really good way of doing that. But if you're reading a blog that someone did this a year ago, maybe reevaluate that.
Yeah, I think doing your own research is extremely important.
DYOR.
Compiling research that you find from others. Yeah, DYOR. And then also not being afraid to ask questions. I think sometimes we're worried we're going to come off as dumb or an imposter, so we don't ask questions. But really, the people who ask questions are the ones that are getting the answers needed to be able to learn more. So you're not dumb if you don't know something, but I would argue it's not a great way to go through life never asking questions that you have. So ask the questions that you need to know, ask different people, compare, and come together, put that together to make your own opinion on what you think is accurate.
I still get messages as like, is this Bitcoin thing real or like legit? So probably those questions would be better.
Yep, people are like, you left higher ed to do what? Why? Like, I love it. That.
Yeah.
Well, thank you both so much for joining. I really appreciate this. I think that we need to keep having these conversations about how to continue to educate others and ourselves in order to make the space safer and to increase adoption of Bitcoin and Ethereum and other important blockchains.
Right. Thank you.
So thank you. Appreciate it. Contact information is in the YouTube video description. So if you want to connect with Jeremy or Shayan or myself, our Twitter handles are there. And I'll also put your website, Jeremy, as well, because that links to a lot of good information too. So thank you so much, and have a lovely